to look at statistical methods for analyzing paired samples in Python using Jupyter Notebook. But before we proceed, I'll urge you to kindly take a look at my previous tutorial video on the flowchart for classifying data, because in that video tutorial I have illustrated and explained the data structure for paired samples, which will help you to catch up with everything that I'm going to do in today's tutorial video. Okay, so you can just click on the link in the card above or check the link in the description of this video. Alright, so like the two sample data or the independent samples, we have parametric tests and non-parametric tests for analyzing such data. The same applies with paired data or paired samples. So the type of parametric test for paired data is known as the paired t-test or the dependent t-test, sometimes called the repeated measures t-test. So this test basically compares the means of two measurements taken from the same individual object or related unit. For example, researchers may wish to compare the means of a pre-test or post-test samples in which a factor is measured before and after an intervention, or researchers may wish to compare the means of a crossover trials in which individuals are randomized to two treatments and the same individuals are crossover to the alternative treatment. There are some assumptions that must be satisfied before this test can be used. One of the assumptions is that the data must be continuous, and the next one is that the data or the difference for the match pairs follow the normal distribution. Okay, so now let's take a look at the non-parametric test for paired data. This is known as the Wilcoxon Signed-Rank test. This test basically compares the medians of two measurements taken from the same individual object or related units. For example, researchers may wish to compare the medians of a pre-test or post-test samples in which a factor is measured before and after an intervention, or researchers may wish to compare the medians of a crossover trials in which individuals are randomized to two treatments and the same individuals are crossover to the alternative treatment. Alright, so there are some conditions which must be satisfied before this test can be used. One of the conditions is that the data must be continuous, and the next one is that the data or the difference for the match pairs does not follow the normal distribution. Another way to analyze the non-parametric test for paired data. Another test that we often use is the sign test. Okay, so the sign test can also be used for paired data. Now let's take an example. Um, A psychiatric hospital performed an experiment to compare whether a record score in which instructions to form images of 20 words were given is better than initial record score for which no imagery instructions were given. So some patients were randomly selected in the experiment with the results shown in the attached psych data set. Does it appear that the average record score is higher when imagery is used? We want to conduct a detailed statistical analysis for this problem in Python using Jupyter Notebook. So before we jump into our Jupyter Notebook, let's take a look at the cycle data set in a CSV format. Alright, so here we go. So we have this data set as a cycle data set, and we have 6 variables specifically. The first one is for the observations. So we have 5 variables here. We have gender, age, height, no imagery, and imagery. Basically, we are interested in these two, no imagery and imagery. So this no imagery variable basically shows the record score for the patient when no image instructions was given, while this imagery variable shows the record score for the same patient when image instructions was used. So it is the same individual with two different measurements, and we want to compare if the average record score is better when this image instructions was used. Yeah, so now, but before we deal with analysis, one thing that you also have to note here is that um, the observations are in two groups. If you look at gender variable here, we have gender 0 and gender 1. So let's assume gender 0 is the female group and the gender 1 is the male group. So in our analysis, what we're going to do is that we are going to determine the average record score for this group, which is the gender group 0, and we also determine the average record score for gender 1, right? And then the last thing that we are going to do is to combine these two groups, that is to determine the average record score for all the observations. Okay, that's going to be the last part. So that's basically what we're going to do. So now let's jump into our Jupyter notebook. Alright, so the first thing that we want to do is to import our data set, and we need a library known as the pandas library, which contains certain functions for data analysis. Okay, and you can also get some functions to import our data set. So let's quickly run this. So control enter. Alright, so it's still compiling. Once it's done, we can load our data set. So I'm assigning my data set to data. So from the pandas library, I'm using the function int underscore CSV, okay? And the name of the data set is scicad data set, okay, with extension CSV. So make sure that I'm going to leave this data file in the description of this video so that you can download it. Make sure that this data file is in the same folder where you have your Python source file or the script file. So let me show you this. So in this folder where I have my Python source file or the script file and the data file. So make sure that you have the same the data file in the same folder where you have your Python source file, so that you don't have to create a new working directory for in your analysis. Okay. So once this is done, we can then load our data set. So control enter. Alright, then let's view our data set. Basically, I want to check the first 5 observations. So we are using .herd. So control enter. Alright, so here we go. We can also get a structure of our data set by using this code of line. So let's run this. Alright, so we have 25 entries, index from 0 to 24, and we also have 6 columns. So these are the 6 columns. 0, the index 0 is ID, right? And you can see for all these variables, the data type is integer 64, which is basically numeric. But we know that gender is a categorical variable, so in our data manipulation, we are supposed to encode this by converting it into a categorical type. So let's quickly do that. So in our data manipulation, we want to recode a gender into a categorical variable. So from our data, we are interested in the variable gender and want to convert that into a categorical type. Let's run this. Control enter. Alright, so now let's look at the structure of our data set now. Control enter. So when you scroll down, you can see that now the gender has been converted into a categorical type, so we are good to go. Alright, so now the next thing that we are going to do is to start with how to determine the average record score for gender 0, which is the female group. So basically we want to extract this, filter this, only this, right, these observations, and just get their imagery and no imagery, these ones, okay, and try to find out if when imagery instruction was used is better compared to when no image instructions. Okay, so now let's go back to our Jupyter notebook. So let me scroll down. So I want to determine the average record score for group 0. So I want to filter image, no imagery and imagery for group 0. Okay, so I'm assigning my data set to G0. So for my data set, I'm interested in the variable gender, but specifically I want to get the label 0, which is for a female, and I want to filter the variable no imagery and imagery. Okay, so let's quickly run this to see the effect, and I want to see the first 5 observations from this data set. So control enter. Alright, so here we go. Alright, so we have basically filtered these ones for group 0. Okay, these observations. Okay, that's the end for group 0. Okay. Alright, so once we are done with this, we want to add the difference of the match pairs to the data set. Basically, we want to take the difference for imagery, this minus that, this minus that, this minus that. Okay, so let's quickly do that. Control enter. Alright, so here we go. So the next thing that we're supposed to do before we start with our main analysis is to do some expert data analysis, but I'm going to skip that for now. If you want to learn how to do expert data analysis in Python, but you can check out my video tutorial by clicking on the link in the card above, or check the link in the description of this video. Okay, so basically we are going to start with assumptions. Okay, so let's start with a parametric test. So first of all, I want to determine if the data is continuous, and you can see that these values are already continuous. Okay, they are basically numeric. And the next assumption is to check if the difference of the match pairs is normally distributed. Okay, so we want to check if this is normally distributed. So let's start with the KK plot. So now to make use of KK plot, we need this library, import scipy start as SS, and also we want to import the pylab library. So let's quickly run this. Control enter. So once we are done, we want to get a QQ plot of the match pairs difference for group 0, okay? And I'm assigning my plot to QP0. So from the CPy stat library, I'm basically going to use a function propplot. So this is my data set, and I'm interested in the variable. The dot diff is for the variable diff, that's the difference of the match pairs, and I want to check if it's not distributed, okay? So it's still compiling. Okay, once it's done, we're going to run this. So the asterisk means it's still compiling, okay? Once it's done, we are going to run this code offline. So let me run this. Don't know why it's taking too long. Control Enter. So another way to basically check for the normality test, right, is to make use of other tests like the Shapiro-Wilk test and the Anderson-Darling test, okay? So we have them here. And to make use of the Shapiro-Wilk test or the Anderson-Darling test, we need a library. We want to import the Shapiro and the Anderson function from the CPy stat library. Okay, so here we go. So now we can see that the plot can start a pointer on the straight line sloping upwards to the right, which is an indication that the difference of the match pairs for the group 0 data set is normally distributed. Sometimes if you have doubt with this, you can make use of the other test, right, like the Shapiro and the Anderson-Darling test. So let's quickly run this. Control Enter. Alright, so now let's get the Shapiro-Wilk test of the match pair difference. So let me run this. Control Enter. Alright, so I'm interested in this p-value. This is the statistic value, and this is the p-value. I'm going to compare this p-value to the alpha level at 5%, okay? And the decision is that we are going to reject the null hypothesis if this p-value is less than or equal to the alpha level at 5%. But because this p-value is greater than the alpha level at 5%, it means that we are failing to reject the null hypothesis and conclude that the match pair difference, right, for this data set is normally distributed, okay? Let's check that of the Anderson-Darling test. So Control Enter. Alright, so here we have test statistic with critical values, and we are interested in the critical value at 5%. So 5% is the critical value 0.68. Now the decision is that we are going to reject the null hypothesis if this test statistic value is greater than the critical value, okay? Now because this test statistic value is less than the critical value, you are failing to reject the null hypothesis and conclude that the match pair difference for this data set is normally distributed, okay? So once we know that all the assumptions has been satisfied, we know that we are going to make use of the parametric test, which is basically the paired t-test, okay? Alright, so now let me scroll down. So we can state the null hypothesis as the mean record score for group 0 is the same when imagery is used, and alternative we can state it as the mean record score for group 0 is better when imagery is used. In other words, you can also say that the null hypothesis, you can state it as the matched pairs difference in the mean record score for group 0 will be equal to 0, and alternative we can state it as the matched pairs difference in the mean record score for group 0 will be greater than 0, okay? Alright, so this is the pair t-test function. So from the CPy stat library, we want to make use of this function t-test rel, which is the relative or related groups. So basically we want to start with the first argument being the imagery before no imagery, because it's going to take the difference with the first input, then the second input will come, okay? It's going to be this minus that, okay? So let me show you this. This is how the null hypothesis will look like. So we are going to have it in this form. We want to state, so this is the first argument. I want the imagery to come before the no imagery, so that The null hypothesis will look something like this, or it will look something like this, so that once we take the difference, it will be equal to 0. Or we can also, so that the alternative will also be in this form. Once the first argument is no imagery, and this is the second argument, the first argument is imagery, and the second argument is no imagery, then we can have the alternative in this form, so that we can have the alternative, this being greater. We are going to specify this in our computation that the alternative should be greater, okay? Or we can also have it in this form. Once we take the difference, it should be greater than 0, okay? Alright, so let me go back to my Jupyter notebook. So imagery first, right? From our data set, we need the imagery and no imagery. Then the alternative should be greater, okay? Because we want to find out if this one is better compared to this. So let's quickly run this, Control Enter. Alright, so now if you look at the p-value, if you have to compare this p-value to the alpha level at 5%, it means that we are going to reject the null hypothesis, because this one is less than the alpha level at 5%. So it means that we are going to reject the null hypothesis and conclude that the mean recurrence score for group 0 is better when imagery is used. In other words, you can say that there's enough evidence to indicate that the matched pair difference in the mean recurrence score for group 0 is greater than 0, okay? So when image instructions was used, the performance was better compared to when no imagery was used. Now let's assume that the normality test failed. Then it means that we are going to make use of the non-parametric test, right? Specifically the Wilcoxon Signed-Rank test, okay? So assuming the normality test failed, then we are going to make use of the Wilcoxon Signed-Rank test. So the null hypothesis, we can say that the median recurrence score for group 0 is the same when imagery is used. The alternative could be that the median recurrence score for group 0 is better when imagery is used, okay? Alright, so this is the function that we're going to use to get our Wilcoxon Signed-Rank test. So from the CPy start library, we are going to make sure of this function Wilcoxon. So we are starting with imagery, right? Before no imagery, then the alternative is greater. Okay? So let's quickly run this to see the effect. Control Enter. Okay, so this is just a warning message. We are interested in this p-value compared to the alpha level at 5%. It means that we are going to reject the null hypothesis and conclude that the median recurrence score for group 0 is better when imagery is used. In other words, you can say that there's enough evidence to indicate that the matched pairs difference in the median recurrence score for group 0 is greater than 0, okay? Alright, so we are done with the first part, which is for the female group, which is group 0. Now I want to determine the average recurrence score for group 1. So in here we want to filter the no imagery and imagery for group 1. So I'm assigning my data set to gen1. So for my data set, I'm interested in the variable gender and the label 1. I want to filter no imagery and imagery, okay? So this is basically what we want to do. Let me show you quickly. Alright, so now we want label 1 for gender, which is a male group. So let me see. So we want to filter this, right? So only this ones. Then we are interested in the corresponding, this one is no imagery, so we are going to pick these variables, okay, and determine if this one is better compared to this. So that's basically what we're trying to do here, okay? So let's run this, Control Enter. So here we go. Alright, so now the next thing is to add the difference of the match pairs to the data set. So I want to take the difference, okay, for imagery and no imagery. I want to add this difference variable to this data set. This minus that, this minus that, this minus that, okay? Let's run this, Control Enter. So here we go. Alright, so the next thing is to test for the assumptions. So first of all, we know that this one is already continuous, so we want to test for the normality assumption, and want to start with a QQ plot. So I'm assigning my plot to QP1, right? So from the CPy start library, the probability plot function is used, and if like the way we did the first one, and close this. Okay, so once you bring the data set, you bring the variable of interest. You want to check if it is normally distributed. So let's run this, Control Enter. Alright, so you can see that some of the points seems to um, uh, follow the straight line, some to deviate from the straight line. So with this, you may have some doubt whether it's normally distributed or not. So let's try and rely on the other tests like the Shapiro and the Anderson-Darling test. So let's check in here. I want to get a Shapiro-Wilk test of the match pair difference for group 1 data set. Control Enter. Now looking at this p-value compared to the alpha level at 5%, it means that we are failing to reject the null hypothesis and conclude that um, there's enough evidence to indicate that the match pair difference for the group 1 data set is normally distributed. Okay, now let's take a look at the Anderson-Darling test. Control Enter. So test statistic, I want to compare to the critical value at 5%. This is the critical value at 5%, 0.68. This is the test statistic value. So because this test statistic is less than the critical value at 5% level of significance, we are failing to reject the null hypothesis and conclude that there's enough evidence to indicate that the matched pairs difference for this data set is normally distributed. Okay, so now that we are clear that all the assumptions have been satisfied, we are going to make use of the parametric test, that the pair t-test. So the null hypothesis, we can say that the mean recall score for group 1 is the same when imagery is used, and alternative, we can say that the mean recall score for group 1 is better when imagery is used. Okay, so let's look at this function. So from the CPy start, we are using this function. So we want to start with imagery. Before no imagery, then alternative will be great. Okay, so let's run this. Control Enter. Now comparing this p-value to the alpha level at 5%, it means that we are going to reject the null hypothesis and conclude that the mean recall score for group 1 is better when imagery is used. In other words, you can say that there's enough evidence to indicate that the matched pair difference in the mean recall score for group 1 is greater than 0. Okay. Alright, so assuming the normality test failed for this data set, we are going to make use of the nonparametric test, that is the Wilcoxon Signed-Rank test. So we are going to state the null hypothesis as the median recall score for group 1 is the same when imagery is used, and alternative is going to be the median recall score for group 1 is better when imagery is used. Okay, so there's going to be a function for the Wilcoxon Signed-Rank test. So we are going to start with the imagery before no imagery, right? Then the alternative is going to be greater. Don't forget this one is gen1, okay, dot imagery, so that's a variable of interest. Now let's run this. Control Enter. So let's look at the p-value. If you have to compare this p-value to the upper level at 5%, it means that we are going to reject the null hypothesis and conclude that the median recall score for group 1 is better when imagery is used. In other words, there's enough evidence to indicate that the matched pair difference in the median recall score for group 1 is greater than 0. Alright, so the last thing that we want to look at is how to determine the average recall score for all the observations. Okay, so now I want to determine the average recall score for both groups, that's all the observations. Let me quickly show you this. So we want to now consider all the observations that we have here, okay, and the corresponding these variables. Okay, I want to look at for the whole group. Okay, so from our data set, we want to get it add the difference of the match pairs to the data set. So we are starting with imagery minus no image. Okay, so let's quickly run this. Control Enter. Okay, so once we take the difference, this minus that, this minus that, this minus that, this is what we're going to get. Okay, alright, so the next thing that we're going to do is to test for the normality assumption. So KK plot, so I'm assigning my plot to QP. Right, so for my data set, I'm using the diff variable. I want to check if it's not distributed. So let's run this. Control Enter. Alright, so when you scroll down, you can see that most of the points are on the straight line sloping upwards to the right. So we can say that the distribution of the match pairs difference, right, for all observations is normally distributed. right? You can also rely on the other test like the Shapiro-Wilk test and the Anderson-Darling test. So now let's check that of the Shapiro-Wilk test. So control enter. So we can see that compare this p-value to the alpha level at 5%, we are failing to reject the null hypothesis and conclude that there's enough evidence to indicate that the matched pair difference for the data set is normally distributed. Okay, let's check that of the Anderson-Darling test. Control enter. So let me see. We want to compare this test statistic to the critical value at 5%, which is 0.703. Okay, so because this test statistic is less than the critical value at 5%, we are failing to reject the null hypothesis and conclude that the matched pairs difference um, for both groups or for all the observations is normally distributed. Okay, so now that we are clear that all the assumptions for the parametric test has been satisfied, we can make use of the parity test. So the null hypothesis, we can say that the mean recurse score for both groups is the same when imagery is used. An alternative, we can state it as the mean recurse score for both groups is better when imagery is used. Okay, so the parity test, we are going to start with data.imagery, right? That's a variable of interest. Then from this data set, we are interested in no imagery as our second argument. Then the alternative should be greater. Okay, so control enter. Alright, so we want to compare this p-value to the alpha level at 5%. Because this one is less than the alpha level at 5%, we are going to reject the null hypothesis and conclude that there's enough evidence to indicate that the mean recurse score for all the observations is better when imagery is used. In other words, you can say that there's enough evidence to indicate that the matched pairs difference in the mean recurse score for all the observations is greater than 0. Okay, so assuming the normality test failed for all the observations, then we are going to make use of the non-parametric test, that is the Wilcoxon Signed-Rank test. So the null hypothesis, we can state it as the median recurse score for both groups is the same when imagery is used, and alternative, we can state it as the median recurse score for both groups is better when imagery is used. Okay, so this is going to be the code to get the Wilcoxon Signed-Rank test for all the observations. So we are going to start with imagery, no imagery, right, from our data set. Then the alternative will be greater. So let's run this, control enter. Alright, so compare this p-value to the alpha level at 5%. It means that you're also going to reject the null hypothesis and conclude that the median recurse score for both groups is better when imagery is used. In other words, we can say that there's enough evidence to indicate that the matched pairs difference in the median recurse score for all observations is greater than 0. Okay, so this is basically how to perform a detailed statistical analysis for paired samples or paired data in Python using Jupyter Notebook. Please, if you find value in today's tutorial video, don't forget to subscribe if you have not, and also turn on a notification bell to get more updated into my posts on this channel. Thank